Hi guys, in today's video we are going to talk about interrupts. So let's get started. In this video we are going to cover hardware interrupts, software interrupts, the sequence of events involved in handling an IRQ and handling multiple devices. These are the contents of today's topic. So generally what is interrupts? The interrupts is a signal from a device attached to a computer or from a program within the computer that requires the operating system to stop and figure out what to do next. So basically this is interrupt. In input output devices, one of the bus control lines is dedicated for this purpose and is called the interrupt service routine, which is generally called as ISR. So it alerts the processor to a high priority process requiring interruption of the current working process. So I think you have a better understanding of what is interrupts. Next we'll see what is hardware interrupt. So basically hardware interrupts is all the devices are connected to the interrupt request line. A single request line is used for all the devices. A single request line is used for all the end devices. To request an interrupt, a device closes its associated switch. When a device requests an interrupt, the value of INR is the logical OR of the request from individual devices. So, the next topic is the sequence of events involved in handling an IRQ. So, basically, the device is informed that its request has been recognized and the device deactivates the request signal. The requested action is performed, an interrupt is enabled, and the interrupted program is also resumed. The device raises an IRQ. Then the processor interrupts the program currently being executed. Then we are going to see about handling multiple devices. How can we handle multiple devices? When more than one device raises an interrupt request signal, then additional information is needed to decide which device to be considered first. The following methods are used to decide which device to select. So there are three methods involved in this handling multiple devices: polling, vectored interrupts, and interrupt nesting. These are explained as following below. We are going to take a look in detail of what is polling. In polling, the first device encountered with the IRQ bit set is a device that is to be serviced first. Appropriate ISR is called to service the same. It is easy to implement, but a lot of time is wasted by interrogating the IRQ bit of all devices. Next, what is vectored interrupts? In vectored interrupts, a device requesting an interrupt identifies itself directly by sending a special code to the processor over the bus. This enables the processor to identify the device that generated the interrupt. A special code can be the starting address of the ISR or where the ISR is located in memory and is called the interrupt vector. So next we are going to see the third method, that is interrupt nesting. So in this method, the input output device is organized in a priority structure. Therefore, an interrupt request from a higher priority device is recognized, whereas a request from a lower priority device is not. The processor accepts interrupts only from devices or processors having priority. So this is interrupt nesting. So I'll show you guys the program flowchart for interrupt. You can have a look for it for 10 seconds. I'll display it for 10 seconds, and then you can take a screenshot or snapshot of this slide for future references and purposes. Okay, I think you have taken look of this flowchart and you would have got a better understanding. So next we'll jump into software interrupts. So what basically software interrupts? The processor requests a software interrupt upon executing particular instructions or when certain instruction conditions are met. Every software interrupt signal is associated with a particular interrupt handler. So software interrupts may also be unexpectedly triggered by program execution errors. These interrupts are typically called traps or exceptions. So I think I have given you an overall idea of what is interrupts. I hope you like this video. Thank you.